Hello friends, welcome in Pharma-info with Shubhashish. Myself Shubhashish Banerjee. Basically I am a person of pharmacy background. I have been with the institution, that is pharmacy institution, for the last 13 years and serving that institution, and basically I am dealing with the subject that is medicinal chemistry, then organic chemistry, then drug design and discovery as well. Okay, before wasting much time in introducing myself and all, let us just come to the point, right? Actually, what for I am here. So for the first time I am appearing in front of you. Now, today the topic which I have decided, that is your chemistry of sulfonamides. Okay. Now, chemistry of sulfonamides, what exactly chemistry of sulfonamides? Because in the UG courses and all, they have kept, or the PCI, they have kept one chapter that is for sulfonamides, right? Sulfonamide antibiotics. Now, let us just deal with that in a sequential manner. So before just entering into the chemistry in a straight way, let me just tell you that a brief history, or let us just discuss the brief history of sulfonamides, right? So what is this history all about? So long back in the year of 1930s, okay, or early 1930s, basically in Germany, dye manufacturer was there, and certainly the manufacturers, or rather the CEO of that particular, one of that organization, he thought that, okay, let us just deal with that dye in a different way. That means in a different way. What does it mean in a different way? Different way means he thought that, okay, let us just pick one dye from that entire pool and just project it into a human being, and who knows, all on a sudden we may end up with some biological effect, right? So with that idea, he just hired one physician, right? And the physician, namely Dr. Domack. Now let me tell you about Dr. Domack, right? The physician himself, okay, he is a doctor by profession, at the same time he is a chemist as well. Now, as hired by the company people or the dye manufacturer people, okay, the doctor straightway, he just picked one compound, right? He just picked one compound that is definitely a dye, right? Initially it was dye, it is a dye only, right? So while being picked from that entire pool, and suddenly the Dr. Domack walked on that particular compound, the one which he picked from the entire pool, and the compound is nothing but Prontosil. So this was the compound which was pulled by Dr. Domack for the investigation purpose, right? Investigation pertaining to its biological effect, investigation pertaining to its whether will it be useful for the human being or not, or okay. Now let us just deal with the next thing. Okay, as I said, the dye which was picked by Dr. Domack was found to be Prontosil. Okay, and let me just deal with the structure of the Prontosil first. Okay, so this is found to be the structure of Prontosil, right? Okay, once he started the investigation, straightway he just introduced this Prontosil into mice, right? Into mice which are found to be infected with what? Pathogenic microorganism that is nothing but bacteria, pathogenic bacteria, okay? And he conducted two different experiments. One is found to be in vitro and the other one is found to be in vivo, right? Okay. Now coming to the output aspect and all, okay. So what happened here, while dealing with the output of in vitro study, it was not found to be encouraging, rather it failed. It failed to develop what? It failed to develop antibacterial effect. But while dealing with the in vivo study, what he observed, the observation was found to be very encouraging. Why? Because it is the in vivo study that clearly indicated that Prontosil did possess an efficacy to stop the growth of the pathogenic bacteria. Okay, so this was the outcome, okay, of in vivo study. Okay, now further investigation of this in vivo study resulted in, or it revealed another things that is quite interesting. Okay, now why this in vitro failed? Okay, what was the reason? But in vivo it got clicked. How How did it happen? So while investigating it further, what he thought, let us just deal with the structure. Let us just deal with the structure. Now while dealing with the structure, he came to know that it is one of the metabolite. It is one of the metabolite of protosil which was responsible for the biological effect. That is, the bacteriostatic effect emerged out of this metabolite. That means the contribution was coming from the metabolite. And the metabolite, later on, he named it as this was the metabolite, right? Which was responsible for what? Which was responsible for the biological effect. And the biological effect was nothing but bacteriostatic effect. Okay. So the biological effect was found to be the bacteriostatic effect. Okay. Now, so this was the compound, or this was the active metabolite which was responsible for the bacteriostatic effect. Okay. Now, and the moment he identified the active metabolite, he just named the active metabolite as sulfanilamide. From that time onwards, they started their journey in exploring what? In exploring sulfonamide drugs supposed to be used as an antibiotic. Okay, now let us just deal with, so this was the background. This was the background behind developing what? Sulfonamides as an antibiotic. So it was the sulfanilamide that paved the way, or rather that unveiled the mystery behind what? Antibiotics. Now let us just move to the next one, that is the chemistry, right? The chemistry of sulfonamide, right? So chemistry. What is the chemistry? Now before getting into this chemistry part and all, let us just deal with another aspect. Okay, at least with that we can get to know about the tit and bits of sulfonamides or sulfonamide antibiotics, or to be more precise, sulfur drug. Okay. Now they have framed, somebody has put it very nicely. Okay, he framed one mnemonic, right? So what is that sulfur all about? Sulfur drugs. So why say, if we just consider this as an acronym, right? Let's just find out the expanded version of it. So sulfonamide, basically, as for with sulfonamide antibiotics, you may find skin rashes, right? So this is found to be the untoward effect rather. Okay, U for what? There is some problem with the urine, that is crystalluria. Crystalluria. Now, coming to this section, there is L. What L stands for? What L can give rise to? L means the duration of action. There is some problem with the duration of action. Some are found to be long acting, some are found to be short acting. Initially, what all the sulfonamides came into existence, they were of short acting. Later on, they thought that okay, chalo, manipulating the structure of the sulfanilamide, okay, gave rise to a long duration of action, right? Okay, so this is found to be the duration of action. F stands for what? F stands for the mechanism of action. That means it is basically affecting folic acid synthesis. And coming to the final one, A for acid. Okay, acid means it is having a resemblance with the structure of PABA. Okay, so with this sulfur, with this acronym, at least we can figure out what exactly sulfur drug comprised of, right? So these are the things, or these are the various attributes of what? Sulfur drugs. Okay. Now coming to the chemistry, right? Okay. So that means we are done with the acronym and all. Okay. We have just now, got the post-mortem report of the acronym of sulfur, right? So with the help of this sulfur, we can readily get to know that what exactly sulfonamides are dealing with and all. Now coming to this chemistry and all. So initially, what all the sulfonamides they developed, starting from sulfanilamide to the subsequent one, they found that pK was found to be one of the serious event. The pK, okay. So that time the pK of sulfonamide was found to be close to 10.4. Okay, so 10.4 pK. That means the pH of the sulfonamide should raise to 10.4 so that we can find 50% of the drug in their ionized form. right? So at a pH of 10.4, then only we can get the drug in their ionized form, and that to 50%. That means there is every chance that the drug may be, the drug may be in the form of a crystal. You can find the trace amount of drug in the form of a crystal, and there is every chance that through the urine you can find a trace amount of crystal. So that is why crystalluria was found to be the serious event, okay, associated with the application of what? Sulfur drugs. Okay, so this was the serious event. So later on they thought, okay, chalo, and moreover you can find the pK of that urine, or pH of that urine is found to be 6.4, max to max 7.7. But when the subject is found to be suffering from urinary tract infection, pK or pH is found to be even less than that of 6.4. So this was the problem. So the drug itself is having the pK of 10.4, whereas the urinary pH or pK is found to be near to 6 to 7, right? So this was the problem. So that means crystalluria was found to be one of the serious event, right, associated with the application or usage of what? Sulfonamides. Okay, so how this can be avoided, how the crystal formation can be avoided, okay, and for that, in that process, what they thought, let us just deal with the chemistry of sulfonamides, so that manipulation of the structure of sulfanilamide or the template compound may give rise to some way by which we can avoid or we can terminate the formation of crystal in urine. Okay, now, okay, let us just consider this as a template compound. That means the active metabolite obtained from brontosil, okay, which exhibited antibacterial effect, and that is bacteriostatic effect, right? Okay, now let us just deal with the template structure so that we can find the area which is responsible for what? Which is responsible for the probability of finding crystals in the urine. That means the crystalluria, I mean to say, right? Okay, so what they observe, why the pK is found to be 10.4? Which is that part, or which is the functional group that raises the pK to 10.4? Okay, so in search of that particular problem, what they identified, this is the area which is responsible for raising the pK to 10.4. That means working in this particular area may lead to the what? Downfield shift of what? The pK from 10.4 to close 6 to 7. Okay, and nowadays what all the sulfonamides that are available in the market, you'll find most of them, their pK is within the range of 6.4 to 7.4. Okay, and so that application of this sulfonamides, definitely we can avoid the chances of finding crystalluria to the subject or to the patient, right? Okay, now, so that means this is the area. So with that, probably we are done with what? The few chemical aspect of what sulfanilamide. Now let us just straightway move to the SAR study. So that we can, at least with this, we can, with this particular problem, we can get to know that this is the area which has to be altered, which has to be modified, so that we can bring down the pK from 10.4 to 7, close to 6 or 7, right? Okay, now let us just deal with the SAR study of what? SAR study of sulfonamides or sulfur drugs. Now, so SAR, that means first and foremost we need to bring the template structure. So this is found to be the template structure. Okay, so this is the template structure. I'll just put here R, right? R. Okay, so now let us just deal with one by one. So this is the area, we'll just call it as site 1. Site 1. This is the area, we'll call it as site 2. And this is the area, we'll call it as site 3. Now we'll discuss one by one, right? Let us just deal with this. We'll just start from this end, right? Coming to this amino portion. So what is that amino? Now, let us see that what kind of scopes are there, okay? What can be done with this amino? Shall we just keep it as such, or will it require any kind of substitution or not? So what they observe that maximum antibacterial or bacteriostatic effect to prevail, the amino should be unsubstituted. That means it is the unsubstituted amino group linked to the aromatic ring, which is found to be one of the prerequisite. That means in order to retain the antibacterial effect or bacteriostatic effect, it is the unsubstituted amino that is found to be one of the prerequisite or one of the essential criteria, what I mean to say. Now, so that means amino should be retained as such. So as I said that this amino which is linked to this aromatic should be unsubstituted, but there is an exception, and that exception still prevail or still in the market, right? That exceptional compound rather, which is not obeying the classical requirement of this sulfonamides and all, okay? And that is nothing but mefenamide or mephenite, sorry, not mephenamide, mephenide acetate. So mephenide acetate is found to be the drug which is still in the market, though most of its predecessor, they are found to be extinct one, but still it is reigning the market like anything in combination with some other drug, some other mainstream drug, right? Okay, so in mephenide sodium, the exceptionality observed. So you can find the exceptionality in case of mephenide. Okay, being a sulfur drug, but mephenide is not obeying this criteria. Okay, so you won't find this criteria to be matched up with mephenide. Why? Because in between this amino and aromatic, they have inserted one CH2. So this is the alteration which they brought in the structure of mephenide. So mephenide is the one which is not obeying the classical requirement. That is, amino should have a direct connection to this aromatic. The mephenide is the one in which the amino is linked to this aromatic by means of a linker that is nothing but methylenic moiety, right? Okay. So with that we are done with this amino section. Now, for your convenience, let me just make it somewhat legible, right? Okay. For the time being, let us assume that we are done with the N terminal, that is site 1. Now coming to this site 2. As I said, site 2 is nothing but the phenyl, right? Okay. Now coming to this phenyl, what they observed, what they basically fixed, that is, or they are asking us to just deal with this aromatic, right? So what they told that the amino should be directly linked to this aromatic ring, right? Okay. Now coming to this site 2, basically what they are asking us that in order to retain the activity, in order to develop the proper bacteriostatic effect, all you need is keeping the aromatic as such in the form of a phenyl. That means you are not supposed to bring here ring equivalent concept. That means sometimes you may find that the phenyl may be replaced with a ring equivalent, that is either pyridine or thiophene. So we have an ample number of examples there in which this kind of substitution they dealt with, right? Okay. Now coming to this side 2, what they suggest? So they suggested that the amino should have a direct connection to this aromatic ring, and the aromatic should be benzene. You are not supposed to substitute or replace the benzene with some other heteroaryl or some other bigger aromatic ring. That means this is found to be one of the things that need to be kept in developing sulfonamide as an antibiotic, right? Okay. Now coming to the areas of substitution, what they also suggested that these are the areas, that means ortho dashed, meta dashed should be unsubstituted for the proper activity to grow and flow subsequently. These are the areas which should not be touched. That means for the proper antibiotic activity or bacteriostatic activity to grow, these are the areas which should be left unsubstituted. Now coming to the other end of this benzene nucleus, right? Okay. So in this end we have an amino group. Now coming to this area, that means the other area, that means para to this, or we can say this is found to be the first position, this is found to be the para position. So let us see that the groups which are found to be para to each other. So one we have already isolated, that is found to be amino. The next one we need to focus on, right? So now we are done with site 2. Now friends, let us just come to the site 3, right? So let us see what site 3 tells us, or what the site 3 requires basically. So site 3 requires what? A sulfamoyl group. So this is found to be the sulfamoyl group. To that sulfamoyl group, one NH was there, right? Earlier it was simply NH2. If it is found to be NH2, then what we found? We observed that pK is close to 10.4. So this was the problem, right? That means in order to avoid the side effects and all, the pK has to be dropped down to 7, okay, close to 7 rather, okay. In that very process, this should not be left as unsubstituted. That means substituent has to be inserted, and the pattern of the substituent is not found to be hydrocarbon. You're not supposed to give to this NH a hydrocarbon. Usually we have found that probably in case of beta blockers, right? Beta blockers, if you just remember that what we found in beta blockers, there also one terminal amine is there, and that terminal amine is found to be a secondary one, right? And the pattern of substituent at that particular point was found to be the hydrocarbon. That means tertiary butyl or isopropyl or sometimes ethyl as well, right? But here it is not accepting hydrocarbon. Then what? That means we need to search for a particular substituent which not only can elevate the biological activity, but also it will help in bringing down the pK from 10.4 to 7.4. So in that very process, what they observed that, okay, let us bring some electronegative atoms. Okay, as such they cannot bring electronegative atoms because we have an electronegative atom here. How is it possible to connect nitrogen and nitrogen? Yes, it is possible, but yes, there is a problem. There may be a chance of repulsion as well, right? Repulsion, because we have a sulfoamyl group here, and all we want is just to substitute the amino of this sulfoamyl group. How this can be done actually? Okay. So friends, now we need to search for a species which can provide which can hold the electronegative atoms. They are nothing but the heteroaryl ring system. Ring systems. What are those? Some of the examples are like pyrimidine, thiazole, isoxazole. So these are the few ring systems or few ring heteroaryl system, okay, which can aid up the process in bringing down the pK from 10.4 to 7. Okay, why? Because they are possessing, all are having what? Either nitrogen or multiple nitrogen or oxygen or sulfur. All are found to be an example of electronegative atoms. So by virtue of their minus I effect, they are just trying to pull the electron things in, and thereby bringing down the pK from 10.4 to close to 7. Now, the moment we got the pK of like 7, what will happen? We can readily avoid the chance of what? Crystalluria, which was found to be one of the major untoward effects, right? Okay. So if that can be avoided, that means we can safely use sulfonamides, right? Okay. Now, so these are the things. So these are the found to be the substituents which has to be placed here, right? Placed here so that we can bring down the pK from 10.4 to 7. Okay. So with that we are done with what? With that we are done with the SAR of sulfonamides. I forgot to tell you one thing. That is, sometimes it can also be found that the sulfonamides not only acting as an antibiotic, but also the same sulfonamide is contributing in reducing what? In reducing the abnormal blood sugar level. That means this is the moiety which is successfully used in the making of oral hypoglycemic. We have an ample number of examples like your carbutamide, tolbutamide, chlorpropamide. So in that what we found, we have an aromatic moiety here like AR, then followed by CONH, and finally we have the hydrocarbon. So this is found to be the feature of what? Oral hypoglycemic. That means it is the same sulfoamyl group, same phenyl ring, same amino group. In addition to this, a carbamido group or carbamoyl, and to that carbamoyl one hydrocarbon is attached. So this is the thing, this particular template can be further exploited, or it was further exploited in making what? Oral hypoglycemic of sulfonylurea class. Okay, you might be remembering that one. Okay, so with that we are done with what? The SAR study of sulfonamide. Okay, so friends, with that we are done with what? The chemistry, or rather I should say we have basically focused on the SAR, or how we can avoid the adverse reaction or the side effects, right, which are found to be more prominent Okay, so now let us see that what all we discussed, okay, in the past few minutes, right? So in the past few minutes, so the discussion was restricted to the SAR. Okay, we have seen the few introductory part of sulfonamide, but we are less concerned of that introductory part. It just, in order to make it more interesting, I just brought that introductory part, right? And later on, we basically we stressed on this SAR study. In a nutshell, what are the things that we studied here? So what are the basic requirement? An amino. It should be connected to an aromatic ring, preferentially a benzene or mostly a benzene, right? And to that benzene, the other end is occupied with a sulfamoyl group, and to that sulfamoyl group, the NH2 should be mono-substituted. That means we have to put one here, R, right? Now, in order to reduce the pKa, the R has to be substituted with an electronegative atoms, right? And the electronegative atom should be a part and parcel of a heterocycle. So, here we have seen the heteroaryls are found to be the substituent which are likely to be placed at this particular terminal. So, with that, if we just give to a particular skeleton this kind of feature and all, we are expecting that this should become a good bacteriostatic with a broad spectrum. So, with that, we are done with today's discussion. Okay, if you like my video, please do press the like button, and if you really want to if you really want me to appear multiple times, please do subscribe my channel so that it will be an encouragement for me. Thank you once again. Thank you.